I'm Anil Kumar. Welcome to my series on quadratic equations. We are going to learn a strategy to find a quadratic equation when the roots are given to us. Here we'll take a very special case when the roots are rational. You can always learn from me by sending an email on the address given here. You can also check the latest videos on my website, Global Math Institute. We'll have three questions in this particular video to discuss. They are all related with rational roots. Let's go through these questions. Question number one. The quadratic equation f of x equals to ax squared plus bx plus c has roots at 1 plus minus square root of 11. Find the value of the real numbers a, b, and c if f of 4 is equals to minus 6. Very similar to this, here is question number 2. The quadratic equation f of x equals to ax squared plus bx plus c has roots at minus 2 plus minus square root of 7. Find the value of real numbers a, b, and c if f of 1 is equal to f of 2. So once you understand the strategy of solving question number 1, I'd like you to solve question number 2. Question number 3 is slightly different. Determine the quadratic equation in the form of f of x equals to ax squared plus bx plus c, that's the standard form, which has roots at 5 plus minus square root of 17 divided by 4. So these are the three questions for you. You can pause the video, answer the questions, and then look into my suggestions. I hope you remember that when we are given the roots, let's say x1 and x2, in that case, the quadratic equation can be written as a times x minus x1 times x minus x2. Now, since we need to find the equation in standard form, we need to expand this and then write our answer, right? We need to write equation in the form ax squared plus bx plus c. That is how you should be approaching it. Also remember that for an equation y equals to ax squared plus bx plus c, the roots x can be calculated with the formula minus b plus minus square root of b squared minus 4ac over 2a. That could also help you sometimes to answer such questions. Okay, so now let's begin with our strategy to solve such questions. So let's take up example 1 in which the function is given to us which has two roots, one at x plus square root of 11, the other one at 1 minus square root of 11. We're also given a point here. When we say f of 4 equals to minus 6, it means that this function passes through the point which is 4 minus 6. And that gives you a very specific equation. Perfect. So as I said earlier, we'll use this particular concept that the two roots are given to us. In that case, the function can be written as f of x equals to a times x1, x minus x1 times x minus x2, where x1 and x2 are the roots. Now the two roots here are 1 plus minus square root of 11. Therefore, the function can be written as what? A times x minus x1, which is 1 plus square root of 11, and x minus x2, which is 1 minus square root of 11. So we'll begin from here. Now, how do we solve this quadratic polynomial, right? We need to now multiply them. It's better to rewrite and rearrange it. See how? We open the bracket in this stage and we wrote this as x minus 1 minus square root of 11 times x minus 1 plus square root of 11. Now, if I combine the first two, x minus 1 and x minus 1, we could write this as a times x minus 1 minus square root of 11 times x minus 1 plus square root of 11. Now what? Well, at this stage, you do see that we have a form a minus b times a plus b. So when you multiply these two, what do you get? You get a square minus b square, right? So when you multiply these two, you get a square minus b square. Therefore, we can directly expand this as difference of squares. So I wrote this as x minus 1 whole square minus square root of 11 whole square. So that is much faster. You save lot of time. So that is a time saving tip, right? So that is a very important tip to understand. Now it is easier. X minus 1 whole square. Perfect square you can expand as x square minus 2x plus 1, and square root of 11 square is 11. Now you can simplify and write your function. So f of x is a times x square minus 2x minus 10. To find the value of a, what can you do? Use the given point. We know the point is 4 minus 6. So now we are going to use this particular information, f of 4 equals to minus 6. Substituting x as 4 and f of 4 as minus 6, we get our equation in the form a times 4 square minus 2 times 4 minus 10 equals to minus 6. Within the bracket, 4 square is 16, 16 minus 8 is 8, and 8 minus 10 is minus 2. So we get minus 2a equals to minus 6. Solving, we get a equals to 3. So once you get a equals to 3, we get the function 3 times x squared minus 2x minus 10. Multiplying each term with 3, we get 3x squared minus 6x minus 30. And now you can compare what a, b, and c is. And therefore, what do we get? We get a equals to 3, b equals to minus 6, and c equals to minus 30. So that is how you could solve this question. So I hope the concept is absolutely clear. You can now pause the video and answer the second question, which is very similar. The roots this time are minus 2 plus minus square root of 7, and the point is 1, comma 2, right? So the point here this time is, you can say this point P is 1, comma 2. Same concept, and that's what I did here. Once you've done, check with my solution. Okay, so let's go through these steps once again. The roots given to us are minus 2 plus minus square root of 7. I'm writing the function as a times x minus 2 plus square root of 7 times x minus minus 2 minus square root of 7. Open this bracket, simplify, write it as sum and product, correct? This is a very important step. So once you write this as a sum and product, you can write this as difference of squares. Getting rid of the radical sign at this stage is very important. And now you can simplify and write down your function. Once you get your function, use the point. Substituting the point, we can find the value of a. In this case, a is 1, and now you can write down your answer comparing the coefficients. I hope that is absolutely clear. Perfect. Now let's move on to the next question, which is slightly different. Now note here, the question is, determine the quadratic equation in the form f of x equals to ax squared plus bx plus c, which has roots 5 plus minus 17 over 4. So when you see such a root, which is 5 plus minus square root of 17 over 4, right? So this reminds you of minus b plus minus b squared minus 4ac over 2a. Do you see that coincidence? Oh, this is not a coincidence. We know about this formula, correct? Now, this formula can give us direct values of a, b, and c, and therefore the quadratic function. Now, we are not given any point, so what we get in this case is a general equation, correct? So here we get a general equation which can be provided. So the strategy is, we know that for any quadratic function which is of the form f of x equals to ax squared plus bx plus c, the formula to get the roots is minus b plus minus b squared minus 4ac over 2a. Now in this case, we will do the reverse calculation, right? So we'll do reverse. That is, we know what the roots are, right? And from there, we'll get what the equation should be. That's the whole idea. Correct. So, comparing, we can actually find the values of a, b, and c, the coefficients in the quadratic function. Well, starting with the denominator, which is 4, and the denominator is 2a. So that means 2a should be equal to 4 and a equals to 2. So we got our first value, which is the value of a, which is 2. So we can write in our answer 2x squared. Now, the second term, let's look into the term in the numerator. We have 5 in the numerator. So that is minus b. Minus b equals to 5, and that means b is minus 5. And we get minus 5x as the second term in the quadratic function. Now, how do we find c? Well, the discriminant in this particular case is what? Well, the discriminant is 4ac. So 4ac, b square minus 4ac, right? So b square minus 4ac should be equal to the term within the square root, which is 17 for us. Now we can solve this. We know the value of a and b. Substituting the value of b as minus 5, a as 2, we can find the value of c. We get 25 minus 8c equals to 17, and so 8c is 25 minus 17, which is 8. Dividing by 8, we get the value of c as 1, and that gives us the quadratic function, which is 2x squared minus 5x plus 1. So I hope you've understood this strategy. Now this method could have been used to solve the first two questions also. However, it is slightly different. In the first two questions, we are also given a point. Perfect. So you'll have to check which family of this goes through that particular point, and that will involve extra work. And therefore, the strategy adopted for first two was better, right? If the point is not given, then this is a better strategy. So that is how you should actually be solving such questions. So I hope you understand and appreciate how do we solve such questions. So in general, what we have learned here is that in case we are not given any point, we should use the formula, right? But if the points are given to us, in that case, we should use the strategy of x minus x1 times x minus x2 to get the value of the function f of x equals to a times, right? The family. Then substituting the point, which is, let's say, AB, we'll get the value of A. Let me write the point as PQ. So, so I hope you understand how to solve such questions. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.